Good morning, and welcome to this session. So building on what the previous speakers spoke about, I want to address how do we realize the vision of ADN. Once upon a time, it could be in prototyping, in research, in standard, and in the end, how to do that in products. So a few words about me. I've been having a passion for automation, for operations, right? And that's what we have to realize here. So I spent quite some year at Cisco as a fellow in the industry, in the standard, and I want to show you how we could go to the next step of ADN levels. The first thing I want to say is that when there is a problem, it's always a network. We always blame the networks. Let me be sarcastic here. This is never the application, right? The application works fine across the WAN. This is never the server. The server is never overloaded. There are no problems with the server. And this is never the cloud, because the cloud works fine, right? And this is never the end user experience, the end user environment. But actually, it is, because we deal with a new definition of the network. This is everything which is between the end user and what he wants to do on the internet. So the silo domain, they don't work any longer. Or maybe they do if we're able to prove that it's not our domain, the issue, right? So I'm someone technical. And in the industry, we've been adding many new features. And I've been adding to the complexity of networks somehow. And what I want to stress is that this complexity is on the verge of turning against us. What I mean by that is the network becomes way too complex, and as a consequence, too costly. Based on my experience, for every $1 of hardware that you introduced, it takes up to $5, $6, or $7, depending on the situation, to just manage this. And that's something that we want to solve, right? Otherwise, we're not going to grow. But we know we have to go with automation. Google told us, like 10 years ago, if a feature cannot be automated, it does not exist. And that's something I like. We must be able to automate everything, to reduce the ratio of CapEx. And the key thing is that it's at the top there. Customer services impacted. Every single time we've got a customer issue, a service impacted, we need to take an action. That's what we want to do here. What you see there is actually the TMF, Autonomous Network Standard, an architecture. So what I like about that is that you could be doing closed loop at different level, at the resource level inside a network, at the service level as well, and also at the business level. So it means that we've got multiple intent. I want my router to be healthy. I want my service to be up and running with the right KPIs. I want my business to be running. And that's what we're going to do. So based on my previous slides of the network being too costly, I want to focus on the self-assuring part, which is self-monitoring, healing, and optimizing. If we focus on those $5, $6, $7, then we're doing a good job. We saw in one of the previous slides the different levels here. We can go from level 0 of ADN, which is like, I configure everything with CLI. And hopefully, I don't do any mistakes with my access list, right? But it doesn't work. Google, again, they mentioned that it's humanly impossible for someone to do all the changes they want to introduce in networks, with the frequency of changes and with the size of the networks. So we have to go to L1, where we have GUI to help us. We need to go to L2, where we have APIs. And that's why I spent quite some time in industry focusing on Yang, because Yang is a data modeling language. And from there, you could generate APIs. We want to go to L3, where I declare my intent, where I could do closed loop. And up to L3, what we've got is that we've got, We've got the machine assisting the humans. But where we want to go, this is L4 and L5, where the human assists the machine. And the L5 is a nirvana, right? It's like network, behave yourself. But if you think about that, what does it mean? You must have the intent first. You must have the closed loop. You must have the automation. So this is the trick here. And I want to show you how to do that one step at a time. So we could ask ourselves, right, but where is the industry actually? And the answer is like, it depends. If we take like the cloud over there, we could say the hyperscaler, they're at maybe 3, 3.5. First of all, because it's cloud-based, so built with resilience, but also because if they see a problem twice, they just code it, right? I could be looking at data center here. Where is the industry? 2.5, 3.5? Well, the thing with data center is that it's a greenfield environment, a clean topology, the same type of top-of-the-rack switch, the same capabilities, the same thing. So we could apply ML and AI. The most difficult one is actually this one, the carrier. It's the most complex one, multi-vendor, legacy devices, different BUs, domains, etc. I could also mention the enterprise over there. Well, there is not a single enterprise. There are multiple types. It could be government, education, oil, bank, etc. So your mileage varies. And by the way, TMF did like divided all of these by execution, awareness, analysis, decision, intent, and applicability. And we want to move to the right over there, away from the P, that means people, to the S, that means autonomous. And I'm not going to try to convince you today that you have to change. You guys have a plan, whether you're a country or a company. You need to go to ADN, you need to digitalize, you need to introduce ML and AI. That's a fact. I see that in Asia, in Middle East, in Africa, in Europe, in the rest of the world. Let me skip this one. So what do we have to do? If you know about the Maslow pyramid of needs, you know, you need to have like physiological needs, and then social belonging, and then up to self-actualization. Let's try to go through this for networking. The first thing we need, number one there, is that we need to get APIs. And those APIs are generated from data models, Yang-based. And with protocols like NetConf, RESTConf, GNMI. That's the very first thing we need. And then we go into this paradigm, which is data model-driven management. Data model-driven management. The next thing is number 3 here, model-driven telemetry. So let me go to the next slide to explain just this number 3. Well, the thing that we've got is that I configure my network with Yang, with NetConf, with RESTConf. This is my data model. Now I'm receiving telemetry information, but today we still use like syslog message, MIPS, IFIT, IOAM, flows. What we need to do if we want to do the closed loop is actually to use the same data model for configuration and for operational data. Whenever we have that, we are simplifying the problem, because what I configure, I've got the same object I monitor. Otherwise, it's too costly to map English or whatever language syslog message into a configuration. We have to reduce the problem scale with Yang-based telemetry, what you call model-driven telemetry. So if I go back now on the previous slide, now we could be doing number 4, which is closed loop, right? And then we could go to 5, the reduce mean time to detect, mean time to repair. And then we could do component and feature assurance. And now service assurance, the business, right, service. And then we could solve the ADM. And we built an architecture for that. It's based on an IETF standard with 2 different drafts on the right-hand side there. And it works for physical and virtual devices. It works for domain. It's multi-vendor. It's a Siang model to assure your network. And we've been building a prototype for any new strategy in the industry. We also need tools and community. This is what we're having here. So how does it work? I've got a kind of assurance graph there. And whenever you have the customer on the line, you could see at the top like the customer service, the specific instance. And this service will be healthy if all the components it depends on are actually healthy. And that's what we want to do. We want to assure any of these components independently. So it helps answering two problems. When a service degrades, where is the fault? And you're able to see directly that this is the yellow spot there. We've got a VPN data plane issue. But the reverse is even more interesting. Whenever I identify that problem in network. All right. I hope you've been following the previous 10 minutes because it was very interesting. Now let me switch with the new mic. The next thing is even more interesting, that whenever I identify a degrading or faulty component, then I'm able to understand what are all the different service instances that are impacted. So you're able to say all my gold customers are impacted. And your customers could be internal or external, doesn't matter, right? So all of them are impacted. So I'm able to rank what I have to do for all my operational teams, okay? It has always been the issue in the industry that we've got operational counters, but we're not able to see what is the service impact of those counters. So we generate this graph based on configuration, what comes from the controller, but also what we learn from the network. And we're able to see the graph evolving along the time. That means that I could see with the post-mortem, I could see what are the symptoms, what happened, and I could introduce new rules in the system. I could discuss some more with the video if you want in the break. Now, for us, it's a big knowledge graph in which we've got the service instance, we've got the symptoms, we've got the rules, we've got all the knowledge that we want to have in there. And why do I mention that? I'm sure you heard the term digital twin. And actually, I prefer digital maps. It's like whenever you want to go from A to B and use your car, it gives you one pass. And if there is an incident there, you're going to take a different pass. And with this system, it's simply a filtering mechanism on top of the knowledge graph. And we could be having, you know, the network elements, the physical layer, the underlay layer, the overlay layer, the service layer, and the service with the KPIs. And the next step above that is be rerouted with the same KPI, with the same SLA, and find it different ways. So you're going to tell me, right, but where is ML and AI into this, right? So the issue that I've got with data scientists is that they always want a lot of data, all the time, high frequency, right? And what they want is they want to have like clean data with the perfect semantic, with the labeled data. By labeled data, we mean that we know exactly that an incident happened. And we solved that with the previous prototype by looking at the health of components, by looking at all the key metrics that we need per component. And we give that in Yang, which is data model. So we've got the clean semantic. We solved that. The key message on this slide is the third problem. We need to get the intent. I've got this operator in Europe telling me, I spent 2 years doing machine learning and AI on my big data lake. And actually, I have to start again because I don't have the intent of the network. What is the network supposed to do? And that's what we solved with the previous prototype there. Now we could be using the full power of ML and AI to deduce new rules to find the right threshold for a specific network. Okay? So yes, we're using ML and AI full speed now, but the prerequisite was to get the intent. Now, the next aspect to this is, most networks are multi-vendor. So we must be dealing with standards, right? So what I want to put on those slides is a couple of buzzwords so that we could speak during the break. And, okay, if I take again, oops, sorry, this side. If I take again the same TMF alignment here, we've got the two drafts that are about the prototype I mentioned, service assurance for intent-based networking. I mentioned Yang, right. For me, config management is done, right? We've got those data models. We need to execute now. I mentioned that those data models are backward compatible. And if they are, the APIs are backward compatible. In case they're not, this is the standard that we need. Now, on this side, we had to develop our own assurance DSL, domain-specific language, because we could not find one that was suitable for us. And then what we need, this is the per node capability, right? I want to understand what I could be doing with a router. If I want to stream information, a simple example, do I want to stream the counters all the time, or do I want to have on-change? On-change means that if a router is able to send me a counter only when it changes, send it to me. Or like a status of a tunnel. Don't tell me all the time, it's up, it's up, it's up. I just want to receive it's down. But that message is key for us because it becomes a symptom. What else? With this operator in Europe, we're looking at getting the entire visibility. The data plane visibility, where are the packets flowing? This was IPFix. The control plane visibility, where are the packets supposed to go? With BMP, BGP monitoring. And also the entire management plane with Yang. And if we've got this view, then we are in a good shape to solve ADN. And personally, I believe a lot into segment routing v6. Because if you go into segment routing v6, it's because you want to simplify all the protocols that you got in your network. As a consequence, it's the perfect trigger to introduce the way to solve ADN. Because you reduce already the protocols in the network. And here there is a big principle, which is that we want all counters to be sent with UDP, right? As opposed to something reliable. But whenever we've got, as I mentioned, like an on-change, like an event, this one must be sent in a reliable way. That's why we're focusing on those standards as well. In passing, I want to mention something about data mesh. It's a new paradigm shift where actually after the big data lake where we put just everything and we expect someone to find what they want, the data mesh paradigm is that you're going to provide the data as a product to the other domain. Your domain is responsible to provide the data. And you send that to a big platform for others to use. Think about that as a trend. Now, we've got a lot of great products. I'm not going to go through them here. You can see the demos, at least the discussion in the corridor over there. We have them with NCE and Datacom. So let me summarize this with just one slide. First of all, we know we have to do automation. We know we have to go to ADN. We know that we have to solve that with intent first. And after that, with the closed loop, with model-driven telemetry. Now, you could be telling, but this guy is in R&D, so he's too far ahead. Well, actually, what I'm showing here is one slide with a product. And you can discuss it outside there with the experts. And what you see in here is like the intent. This is what I want to get from my network, and I could be configuring all of these, and actually just do click, and it configures. So this is the cloud fabric for data center. What you see on the left here is the digital maps that I've been mentioning. So the things I've been showing in prototypes, in research, in standard, it's not about dreaming, right? We are realizing this in products. And the independent company there rated us for this product at being ADN level 2.5, right? While the industry is still at 2.8. So we are executing on this research prototype and standard. And with this, I'd like to conclude. Thank you.